Okay, it's working. Good. So by lowering powers on cosine, I see cosine has power 4. What I would like to have at the very end, I would like to have cosine x, maybe cosine twice x, maybe cosine 4x, but all of them to have power 1. And you can ask, okay, what is this for? Well, it's very important for Calc 2. When we get to integrals, we cannot determine this cosine, the integral of this. We can't do it, but we can very easily of all these. So if we have a mechanism in place to change this into something like this, as many cosine possible, I don't care how many, but they all have power 1, you will be able to proceed with this. But you are not able to proceed with this. You don't know that yet because that's in Calc 2. Okay, so I'm looking at this and I say, oh, I have a formula. I have a formula that is cosine squared, but I have to square it. Copy the base, multiply the exponents gives me this. And I know the formula for cosine squared, which is 1 plus cosine twice x over 2 squared. Let's go back and find it. Here is the formula. Here it is. Super important. Cosine squared equals 1 plus cosine twice x over 2. And that's what I did. But I had to split cosine to the 4th into cosine squared and cosine squared, or cosine squared to the 2nd power. And then I replaced cosine squared by 1 plus cosine twice x over 2. Now I will square this because I have no other choice. I have to move to the next page, sorry. Okay, that's my page 9. I have to square the top, and I'll have to square the bottom, but I'm going to put 1/4 in front so I don't have to mess with that. 2 squared. And now I square the top. 3 terms. 1 plus twice cosine twice x plus cosine squared twice x. First term squared plus 2 times the first times the second plus the second term squared. Agreed? Okay, now, this is okay. This is okay. It has power 1. But this one is not. I will apply the same formula again. I'm going to distribute 1/4. 1/4 plus 1/2 cosine 2x plus 1/4. And I will replace this by what? Exactly the same formula I used for cosine squared x. I will use it now for cosine squared twice x. Because I showed you once I know the mechanism, I can plug in anything I want. So what will I replace cosine twice x by? Exactly the same formula.
So 1 plus cosine x.
1 plus cosine, careful. The angle now, that's the trick.
Oh,
The angle now is twice x, so then the angle here will be times 2, right?
Yeah.
So what is this? Yes, divided by 2. So now from cosine to the 4th, I lowered the powers to only cosine to power 1. So now I have 1/4. I just need some algebra to simplify, and it's done. 1/2 cosine twice x, and this is 1/8. 1/8 times 1 plus 1/8 times cosine 4x. What I did, I split this fraction into 1/2 and 1/2 cosine 4x, and not multiplied by 1/4. So this is okay, it's done. This is okay, it's done. I only have to add these 2. Is this clear? Do I have to go back?
Yeah.
Where?
The step before.
This one?
So, okay, so yeah.
So 1/4 times 1, 1/4 times 2,
Okay.
1/4 times this. Now I replace this using the same formula I used before. But this time I have 2 here, so I have 4 here. If I have 2 here, I have to have 4 here, as we did before. That's why I prepped you with all this. And you would have probably thought, oh, okay, what's this nonsense for? I needed this, because that's what I'm using, right? So if I have here 4a, then I have here 2a and 2a. So if I have here x, then I have to have here x over 2.
Right.
So
That's right.
then if I have here 2x, then I have to have here 4x.
But how would it not be? Oh, you have to
Yeah, the formula has over 2, right? So I have cosine squared 2x. Cosine squared 2x is 1 plus cosine 4x over 2. That's what we wrote. 1 plus cosine 4x over 2. Is that okay?
So yeah, I guess the 4, we're getting a 4, but the other one we were dividing each one by 2.
That was a different formula. So here I had cosine squared of x is 1 plus cosine 2x over 2. That's the formula for x and twice x. Now I have twice x. That's why I have 4x. It's the same formula, but applied for a different angle. So then I split this into 2 fractions, 1 over 2 and cosine over 2, and then I had to distribute 1/4. That's how I got 1 over 4 times 1 over 2 and 1 over 4 times cosine over 2.
Alright, I see that now.
So now this is done, this is done. Now I have to add these 2. The least common denominator is 8. I have to multiply this by 2, and 2 plus 1 is 3. So 3 over 8 plus 1/2 cosine twice x plus 1 over 8 cosine 4x. Any questions? And we lowered the powers. Look how interesting this is. We started with the cosine to power 4, and we got a sum of some algebraic expression with cosine in it, but all of them have power 1. So when you get to integrating in Calc 2, you don't have to write this. The integral from cosine to the 4th x dx, you will actually integrate 3 over 8 plus 1/2 cosine 2x plus 1 over 8 cosine 4x dx, which is extremely easy, which is impossible. That's one application of lowering powers. Okay, do we need another lowering powers? As you see, it's a long process. It's a long process. I had 1, 2, 3, 4, 5 steps. Okay, let's choose another. Don't choose the power to the 6, because you can do that at home if you want. It will take a while. And I don't want to take the entire time to do that. Choose anything else. Choose the product sine cosine.
Alright, yeah, let's do 14.
14. We are using the same formula over and over. 14 on page 514. And this is cosine to the 4th times sine squared. Now, in order not to reinvent the wheel, I will replace this one because I already have it. Look, I worked on it. It's done. So I'm going to replace this by it. Or we can choose another problem so we can start from scratch.
Well, they're all pretty much.
Let's make one up. Allow me to make one up. Okay? Good. So let's say sine squared times cosine squared. Ready for this? Okay. Sine squared. It's the same formula, but with minus. The same formula we just used a minute ago, but with minus.
1 minus cosine 2x divided by 2.
And the other one, cosine squared.
1 plus.
I pull 1/4 outside. Can anyone give us the answer for a minus b times a plus b? 1 minus cosine 2x times 1 plus cosine 2. Yes.
Why are you nuts putting the square on the outside?
Let's take a look at the formula again.
Okay. So, oh, never mind. I just pointed. You're right. Okay.
Because this is already sine squared. It's not to the fourth. If this were to the fourth, I would have put squared on both. On whatever. Good. So then, so the first term squared minus the second term squared. Okay. Now I still have a cosine that has another power than 1. What do I replace cosine squared of 2x by?
1 plus cosine 4x.
Very good. Very good. Over?
2.
Yes. Excellent. So I'm going to distribute 1/4. 1/4 minus 1 over 8. And in parentheses, 1 plus cosine 4x. I will distribute 1 over 8. 1/4 minus 1 over 8 minus 1 over 8 cosine 4x. And I have to perform the operations. 2 minus 1 is 1. 1 over 8 minus 1 over 8 cosine 4x. Much easier than those powers of 4. Ready for the next set? Say it again.
I'm still writing it down, so.
He's still right.
In the meantime, let's just look between 17 and 28. Use an appropriate half-angle formula to find the exact value of the expression. Any preference? No? No. Okay, I'll choose then. Let's say 17, sine 15 degrees. Is this clear now, everyone? The previous problem? Is that okay? Yes?
Okay, see. Yeah.
Any questions? Okay, very good. So we want to use a half angle. So I need to replace sine by, I'm sorry, 15 by. Give me something divided by 2 that will give us 15. For now, that's all I'm asking.
Divided by 2 that gives 15.
Yes,
30.
yes. So 30 degrees divided by 2. Perfect. Which formula will I use? Is this an angle in the first quadrant? The sine of sine will be?
Oh. What was the question?
So since the angle is in the first quadrant, the sine will be what sign?
Oh, positive.
Good.
Oh, sine. Okay. So,
Yes.
third
Yes.
minus cosine
Yes? Of what?
30 over 2.
Careful. If this is x over 2, this cannot be x over 2.
30.
Exactly. Divided by? Exactly. How much is cosine 30? 30 is the first angle. Cosine is the second column.
Let's go with 2.
That's the second angle.
It's 1 over 3.
Very good. Divided by 2. Excellent. Find the least common denominator in the numerator. So 2 minus the square root of 3 over 2, everything over 2. So far, so good? So now I flip this, which is 2 over 1. So I get the square root of 2 minus the square root of 3, everything over 4. And then the top is the square root of 2 minus the square root of 3, and the bottom is 2. I took the square root from 4. We use an appropriate half-angle formula to find the exact value of the expression. Let's also look at 24. Any questions? Any questions? So this is 2 over 1. And when I flip, I get, is that okay, everyone?
Oh, yeah.
Yes? Okay, 24. So cosine 3 pi over 8. We're asked to use an angle, a half angle situation. What is it? Cosine of what?
Maybe 3 power 8 over 2.
But if I put 3 pi over 8 over 2, it'll be 3 pi over 16.
Oh, 3 power 4.
Exactly. Good. Now I have to determine which quadrant this angle has its terminal side, because I need to know what.
If it's going to be positive or negative.
Exactly. So let's multiply 3 pi, 3 times 180 divided by 8, and just tell us the quadrant. Divided by 8. Which quadrant?
It is in the first quadrant. You got 67.5.
Okay, good. So everything is positive. So then I know what to write then. This would be
Square root of 1 plus cosine x over about
1 over the square root of cosine what?
oh x. Oh. 3 pi.
This is our x. So this is our x, and this is our x over 2. This is x over 2, and this is twice x.
Oh, so 3 power 8.
3 pi over 4. It has to be the same angle. Look here. Look here. Sine 15 is sine 30 over 2. 1 minus cosine alpha, or cosine x, divided by 2. So then cosine twice x is cosine of x over 2, which is this whole thing. So this is 3 pi over 4 over 2. So this is 1 plus cosine 3 pi over 4 over 2. Good. Now we have to determine cosine 3 pi over 4. Which quadrant is that in? Remember, 3 pi over 4 is 1 pi over 4, 2 pi over 4, 3 pi over 4. So that must be in the...
Second one.
Good. So what is the sign of cosine in the second quadrant?
Negative.
Good. So 1 minus. How much is then cosine 3 pi over 4? And this is the easiest angle to work with.
3 power 4? Oh, power 4?
Yes, because that's a reference angle.
Square root of 2.
Exactly. Thank you. It's the middle angle. So then the same thing, I find the least common denominator. 2 minus the square root of 2 over 2, everything over 2. I flip, take the square root. So the top is the square root of 2 minus the square root of 2, and the denominator is 2. So we use the half angle identity to determine the exact value for cosine 3 pi over 8. Any questions?
So you went from 3 pi over 4 to square root 2 over 2 because of where it landed on the...
Exactly. I have to be, as we know from chapters 5 and 6, when I'm asked to find cosine 3 pi over 4, I say 1 pi over 4, 2 pi over 4, 3 pi over 4. It lands in the second quadrant. Cosine must be negative there. The reference angle is pi over 4. So then cosine of 3 pi over 4 is negative cosine pi over 4, which is negative the square root of 2 over 2. We are building in chapter 7 on what we, that's why I didn't want to put in chapter 4 yet. I wanted to finish with trig first. Okay, are all the calculations okay then? Yes? Okay.
So you're saying after chapter 7, no more trig?
No more trig.
God. Let's get through this.
Okay. Good. Next set. 29 to 34. Simplify the expression by using a double angle formula or a half angle formula. That's why I showed you all sorts of different directions with those formulas for this. Let's say 33b. Or I don't know. You choose. 32b. And then 33b. In 32b, I have 2 sine theta over 2 cosine theta over 2. In 33b, I have 1 minus cosine 4 theta divided by sine 4 theta. And this is one formula I did not discuss yet. That's why it caught my eye. Okay. The first one, what will you say? What does it resemble, first of all?
Half angle.
Yes, of which one? Of sine, of cosine, or tangent? Exactly, it's sine. Good. So then it's sine of what? Of the double angle.
Yeah.
So what do I write?
So 2 sine.
So the question is, what do I put here so that I get 2 sine theta over 2 cosine theta over 2? Okay, let's go back.
Sine theta over 2.
Let's go back. Well, if I put here theta over 2, then I have theta over 4 and theta over 4.
Stick with theta.
Exactly, I agree. Let me show you. That's why I tortured you already with that. Look here. 2 sine theta over 2 cosine theta over 2 must be sine theta. Clear? Okay. So now I want to come back to 33b. And if you have your book, I would like you to open. I'm sorry?
Really?
Yeah. If you would like to open your book on page 510. At the very bottom, you will see the half angle formulas. So let's look on page 510. The bottom blue box. Okay? We recognize sine u over 2, which is plus or minus the square root of 1 minus cosine u over 2. We recognize that, correct? Okay, let me show this. So we recognize this. We used it a few minutes ago. We recognize this. We used it several times a few minutes ago with cosine squared. Cosine squared u over 2 is 1 plus cosine u over 2. And this is a different way of writing this. Okay? So I'm going to give you this formula. I'm not asking you to memorize it. So let's write it down for now. So tangent u over 2 equals, and there are 2 in there, 1 minus cosine u over sine u, or sine u over 1 plus cosine u. This will be given to you. So now we can answer 33b. And please tell me, how will you answer 33b? Look at these 3 formulas that you have, just 2 formulas. These 2 options for tangent u over 2. And tell me, what will you say 1 minus cosine 4 theta over sine 4 theta will equal to?
Sine 4 theta.
Maybe 8
So this is 1 and 1.
theta.
This is minus and minus, right? This is cosine, cosine, and this is sine, sine. So obviously it's this formula. The question is, it has to be a tangent. We agree with that, right? Okay, so
So would it be 8?
yes.
You're trying to get 4.
So careful. this we have to divide this by 2.
Oh, sorry.
Okay? So if this is u, which is 4 theta, u is 4 theta, this must be u over 2, which must be 4 theta over 2, which is 2 theta. So 4 theta is u, but here I want u over 2, which means 4 theta over 2, which is 2 theta. Okay? Can we move on to the next problem, or the next set? Write the given expression as an algebraic expression in x. So please choose 43 through 46. Okay, I will choose, you choose. 46. Okay, so let's look at 46. In 46, we have cosine of twice sine inverse x. What does sine inverse mean?
That
So sine inverse x equals?
Alpha.
Yes, excellent. Which means that what do I do to both sides?
Yes, I know.
Good. So sine alpha equals x. So what I'm really asked to find here, can anyone explain what I'm really asked to find? I'm asked to find cosine of what?
Sine alpha. Yeah, sine alpha.
two times sine. Oh, there's 2 out.
Exactly. I cannot be asked to find cosine twice sine, right? I'm asked to find cosine twice of an angle.
Oh, so this is just the
Right.
double one.
So then this is, anyone give us the formula? Which formula of those 3 you will use? Look at the problem and say, I only want this one.
So last one,
Oh,
2 cosine.
The angle is given as sine inverse. So therefore, I have 3 options. I know I have 3 options for cosine twice alpha. But which one of those, knowing that alpha is given as sine inverse?
you go to the sine.
I only want what in the formula?
Sine.
Exactly.
Okay.
So let's write 1 minus 2 sine squared alpha. But how much is sine squared alpha? Look at what we wrote. Identify it from what is written on my paper. So how much is this? It's written on the paper.
That's 2x.
No, when I square x, I don't get 2x. Sine alpha is x. How much is sine squared?
X squared.
Exactly. That's it. That's all we need to do. Let's also look at 45. Sine of 1/2 cosine inverse. Sine of 1/2 cosine inverse x. Okay, what is cosine inverse x? What does it equal to? What does it represent?
Alpha.
Which means that what? From here.
Sine x.
Cosine alpha equals x. Good. But now I have to figure this out. What am I asked to find? I'm asked to find sine of what?
1/2.
Alpha. Excellent. Okay, I have to dig deep. Since I'm not given information where alpha is,
Plus or minus.
exactly. Excellent. The square root of, and now I have to remember that super important formula. Sine of half an angle is this plus or minus the square root of,
1 minus.
exactly, 1 minus what?
Cosine.
Cosine what?
This is where it's tricky. Alpha.
Exactly. But I know cosine alpha.
It's x.
Right, so this is the square root of 1 minus x over 2. Excellent. Find the exact value of the given expression. 47 through 50. 48 it is. Cosine of 2 tangent inverse 12 over 5. I start from the inside. What does tangent inverse 12 over 5 mean? What does it mean? Tangent inverse. Tangent inverse is not sine over cosine. Yes, indeed. Tangent inverse of 12 over 5 is alpha, which means tangent alpha equals, indeed. So I can jump ahead to a right triangle with an acute angle alpha, whose sides, 2 of those, I know. So this must be the square root of 145 plus 25. That's 169, 13. Good. Now I'm coming back to my problem. I haven't even established what I'm asked to find. So let's establish what are we asked to find. I'm asked to find cosine of yes, 2 alpha indeed. I have to be asked to find cosine of an angle, and it's twice that angle. Now I have to decide which formula to use because cosine twice alpha has 3. It doesn't matter which one you use. But I prefer using the one with only either sine or cosine so I don't have to plug in 2 different things. And I only plug in 1. It doesn't matter which one. You want 2 cosine squared minus 1 or you want 1 minus 2 sine squared? 2, I agree with that. Cosine squared alpha minus 1. So 2 multiplied by, can anyone give us cosine and square it? Let's write the cosine and then we'll square it in a second together. Can anyone give us cosine? Alpha. I disagree. It cannot be 12 over 13 because that is the opposite over the... Excellent. I agree with that perfectly. So this is 2 times 25 over 169 minus 1. I have to square.
Oh, never mind.
So 5 squared, 13 squared. And then this is 50 over 169 minus 1, which is 169 over 169. So 50 minus 169 over 169. I perform the top and I get negative 119 over 169. And this is the final answer. Okay. Next step, let's choose one more from there, 51 through 54. So you have an example from each. 51 through 54. Evaluate each expression under the given conditions. Please choose, or I will.
You take it right.
I'm sorry?
But you can pick.
Okay. I'm going to pick 53. And we have sine twice theta. And we are given sine theta as 1 over 7 and theta in 2. Evaluate the expression. Evaluate sine twice theta if you're given sine theta equals 1 over 7 and theta in the second quadrant. I need the formula for sine twice theta.
Two sine theta, cosine theta.
I already have this piece. How much?
1/7.
Good. I have to determine this. What will be the sign of cosine in the second quadrant? Good. So then I have cosine theta equals negative the square root of this squared. So this will be negative the square root of 48 over 7. Now the square root of 48 should be simplified. So the square root of 48, so it's 4 times, no, it's 16 times 3. Good. So this is 4 the square root of 3 over 7. Now I have this piece. So I want to determine the whole thing, multiply. So 2 times negative 4 is negative 8 the square root of 3 over 49. And this is it.
So you did 2 times 170 times.
Yes, yes, let me write it. So 2 over 7 multiplied by negative 4, the square root of 3 over 7. And I just realized that by mistake I skipped 37 through 42. Please choose 37 through 42. Okay, 38. And we have cosine x equals negative 4 over 5. And we are given this. Find sine x over 2, cosine x over 2, and tangent x over 2. So we want sine x over 2, cosine x over 2, tangent x over 2 from the given information. I'm also going to ask you find also the quadrant maybe. Okay. So which quadrant is this?
It's 3.
Yes. I'm going to divide everything by 2. 180 over 2, x over 2, 270 over 2. I'm allowed to divide all 3 sides in an inequality by 2. So I get here 90. I get in the middle x over 2, and here I get 135. So now I'm going to ask you, if x is in the third quadrant, where is x over 2? Which quadrant is x over 2? Yes, indeed. So x is in the third quadrant, but x over 2 is between 90 and 180, which means the second quadrant. Perfect. Which means sine will be, cosine will be, and tangent will be? Excellent. So let's find x over 2, sine x over 2, which I know is positive, which is the square root of 1 minus, the formula says, which one? Yes, but cosine x divided by 2. So then I will write the square root of 1 minus 4 over 5 with minus minus will become positive divided by 2. Because cosine is negative 4/5 with minus in front will become positive. So then I have 5 plus 4. So the square root of 9 over 5 divided by 2. So this is the square root of 9 divided by 10. You flip 2 over 1 and 9 over 5 times 1 over 2. So this will be 3 over the square root of 10, and we have to rationalize. So 3 the square root of 10 over 10. I have sine. Now I need to determine cosine x over 2. Can anyone give us the formula and the sign in front of the square root? Because you will give me a formula with a square root. But what is the sign? Since x over 2 is in the second quadrant, I have minus. Now please give me the formula. It's the same with the formula for sine x over 2, but the only, exactly. So 1 plus cosine x over 2 minus outside, And now I have 1 minus 4 over 5 over 2. So the top will be 1 over 5 divided by 2. So this is with negative in front, don't forget, because I just did. So this is 1 over the square root of 10, and I rationalize.
So the negatives in front because of the
Cosine, because x over 2 is in the second quadrant, and cosine will be negative in the second quadrant. Excellent, yes. So now, therefore, I'm not going to use the formula for tangent. That's why I'm not forcing you to remember that. Because once you have sine and cosine, you need the tangent. You don't need an extra formula. But if it's needed, it will be there. So final tangent of x over 2 will be sine x over 2 over cosine x over 2. Sine x over 2 is 3, the square root of 10 over 10, over the square root of 10 divided by 10. As you see, these two go away. The square root of 10 over 10 is the top, and the square root of 10 over 10 at the bottom. So the answer for tangent x over 2 will be exactly. As expected, tangent is negative. Now I would like to show you one example. You choose from the product is given, we want to change it into a sum, and then an example given when the sum is given, we want to change it into a product. So 55 through 60. We are given a product, we want to change it into a sum. Please choose one. Let's say 58. We are given cosine 5x times cosine 3x. Okay, let's go to the formula. It is a product or a sum?
Product.
Right. So product to sum formulas. We want to choose the one that has cosine, cosine. Cosine times cosine. Just this one. Cosine u, cosine v is 1/2 cosine u plus v plus cosine u minus v. Ready? So then 1/2 in front. Cosine u plus v plus cosine u minus v. And it's done. That's it. Of course, you cannot combine like terms. Don't even think. Write a sum as a product. Let's say 66. Sine 3x plus sine 4x. Is it a sum or is it a product? It's a sum. So let's look at the formulas. Sum to product formulas. And what we have here is sine plus sine. Sine plus sine. 2. The sum over 2. Cosine, the difference over 2. Yes, yes, yes. So 2. Sine of the sum over 2. Cosine of the difference over 2. 3x minus 4x, negative x over 2. But what type of function is cosine? Because I don't like negative angles.
It's an even.
Right, so cosine negative x over 2 will be replaced by,
Cosine.
that's it. 2 sine 7x over 2 cosine x over 2. Now, we still have time to finish this. I would like you to choose some identities from here. 73 through 90. 73 through 90. And that's the end of this section. Okay.
Now look, reasonably difficult.
I know they look,
Crazy.
yes, I will have to agree. Let's say, I don't know, 77 caught my eye. Sine 4x over sine x, they say is 4 cosine x, cosine twice x. We just picked the problem. I've never looked at this. I have no idea what to do.
Neither I would say both.
I have no idea how I'm going to get from here, and I have no idea how I'm going to get here from here. But I will do something. I will have to do something. So I'm going to start from the left-hand side. And let's think. I have sine 4x over sine x. I'm going to write something, and then you're going to wipe it from your memory forever, correct? I've seen this done.
Looks like something I was before on a test.
You're just missing the cosine. That's all.
Yeah, now I just threw some cosines in there. I got the answer.
This is horrible. This is a function that you cannot simplify with another function. This is an argument inside this function, which you, this is another argument inside this function. You cannot simplify something like this. So please, please. Okay? Please. Okay. So I'm going to come back and start from scratch. So the left-hand side equals sine 4x over sine x. I don't know what to do to sine, but I know something about sine 4x. Exactly. So give me a formula that I could use for sine 4x.
Oh, yeah, sine.
Something that we discussed today and we played with at some point in time about an hour and a half ago.
So 2
Yes.
sine
Yes.
2x
Yes.
cosine
Yes.
2x.
Wonderful. Look, I'm already in one step. I'm closer to the right-hand side. I already got this. So, right? Okay, good.
Oh, so now we just go through
Exactly. Exactly. But initially, I had no idea. But then I thought, okay, I can't start with sine. I have to look at sine 4x. And then everything started clicking, right? Okay, so then I continue. I have to, and now I have a formula that I could use on this. And you already said it. Instead of this, I write, careful,
Sorry.
Cosine.
what do I write instead of this?
2 sine.
2 sine,
X.
yes,
Cosine X.
yes,
Uh,
times cosine 2x. And it's done. And I had no idea how I was going to get it. What goes away?
sine X.
Right. And what is the final form? 4. Yes? Right. And this is the right-hand side. It looks scary. But based on what we know, we had to apply something. Okay, I have 3 minutes. Do you want to start another one, or is it enough for today? You want to do one more, or not?
Whatever. Yeah, let's do it.
Which one?
I'm here for one.
Good.
83.
83. Excellent. I was just looking at 83 to tell you the truth. That caught my eye too. Cosine to the 4th minus sine to the 4th, let's say it's cosine twice x. Now, honestly, on this one, I already have the road in my head. On the previous one, I didn't. On this one, I do. Which side do you start from? Yes, I agree. So now let's look at this. Cosine to the 4th minus sine to the 4th. It resembles something that I have on the agreement from 2 months ago. It's, aha!
So cosine squared.
Exactly. See why I had to do that from the first day of
Minus
classes?
sine squared.
Exactly.
Plus, cosine squared plus sine squared.
Right. See why? Now look at these two and say, ah,
Well, this one could break down again.
So what is this?
That is 1.
Exactly. And what is this?
That's cosine. What, I feel like -1 would be a balance.
Go back to the formulas from today that we discussed today and tell me what cosine squared x minus sine squared x equals to.
Cosine 2a.
Exactly. And it's the right hand side and we're done.